Good morning. I hope you're ready to learn about functions. So with functions, the number one thing to remember is that x does not repeat. Your x values in functions do not repeat. I always tell my students that it's kind of like relationships. My students are 8th graders. They are dabbling in relationships. They have their boyfriends, girlfriends, and I say, when you're dating, what don't you repeat? You don't repeat your x's because, they didn't work out for a reason, right? But no, functions don't repeat their x's just like we don't want to repeat our x's, okay? So let's get started. So with functions, you have your x and your y values. Your x values go with your input, your y values go with your output. Something very important to remember is that every input has a single output, okay? So there are 4 different ways that you can have a function be represented. You have your tables, which is right here. Mappings, which this is what a mapping looks like. This is a very simple mapping, okay? A graph, which this probably isn't 100% accurate, but a graph. And then your ordered pairs, okay? I'm going to show you individually the different ways that you can identify functions from these 4 different mediums. So shown below are 2 different tables. One of these is a relation and one of these is a relation, one of these is a function. One is a function, one is not a function. Okay, so the way that I always have my students pick out, is it a function, is it not a function, is I first of all have them highlight their x values, okay? The y values, to be honest, don't matter, okay? Remember, you don't want your x's to repeat. It doesn't matter if your y's repeat, okay? So like right here, if you ever saw this as a question, here they're trying to trick you. They're giving you a bunch of repeating y's, making you think, oh, I see a repeating number, it must not be a function. When in reality, your y's don't really matter. So you can even just cross out your y's so you're not distracted by them, okay? So now that we've highlighted our x's, crossed out our y's, let's look at our values. On this one right here on the left, it's 1, 3, and 6. That is not repeating, therefore that is a function. Over here on the right, we have -2, 1, 1, 2. Right here, those 1's repeat, therefore this is not a function. Something that tricks up some students is if they see a -2 and a +2, or like a -1 and a +1, they'll think, oh, that's not a function. When in reality, it doesn't make it a function, it doesn't not make it a function. A -2 and a +2 are 2 totally different numbers. So if you had a table like this one, -2, -1, 0, 1, 2. I'm not going to make up any y's because they don't matter, but let's highlight our x's. A lot of students will say, oh, here and here, that makes it not a function. It has -2 and +2. It also has -1 and +1. That doesn't mean anything, okay? If we made a number line, okay, and let's say it was -1, 0, 1, 2, 3, 4, okay? -1 and 1 are 2 totally different numbers, okay? So it doesn't matter if you have the same number just in a negative and positive form, that doesn't make something not a function. Okay, so here we have 2 different mappings. This is, usually it can be kind of tricky, but luckily my students this year have actually picked up on it like perfectly fine. But if you haven't picked up on it, that's okay because everyone's different. So these are 2 different tables, or 2 different mappings, I'm sorry. Here on the left, we have 1, and if you look, every input, which is the numbers on the left, aka the x's, has 1 arrow leaving each input value, okay? That makes it a function, okay? Right here, where there is 2 arrows coming to the 3, that's okay because that's an output, okay? But then when you look over here, there are 2 arrows leaving this input value. That makes it not a function, all right? So an easy way, if that doesn't make sense to you, it's a tiny bit more work, but it's okay because it helps you get the right answer, right? Okay, so something you could do is you could write out all your ordered pairs. So this one would be 1, 3, and then also 1, 4, okay? And then 2, 5, because the 1 has arrows going to 3 and 4, which means 1 will have 3 and 4 as y values, which is why I wrote it out like this, okay? When you write it out like this, it's a lot easier to look at, okay, do I have any repeating x's? Do I have any repeating y's? And remember that your ordered pairs go like this, x, y. Just like the alphabet goes x, y, z, ordered pairs x, comma, y. So if you look right here, your 1's repeat. It checks out that in fact this is not a function, okay? So the third way that you can be given functions is via graph. There is a test that you do to find out, is something a function? Is it not a function? That is called the vertical line test. So you conduct the vertical line test by drawing a vertical line through the graphed line and see how many times it touches the graph. So when I drew a vertical line right there, it touches here and here. It touches twice. If it touches more than once, it is not a function. Therefore, this first one, not a function. It touches twice. It's only supposed to touch once, which you will find happens right here. I drew a line. You can draw it anywhere. You could have drawn it over here. Okay? It only touches once on each line. Therefore, this one is a function. Right here, draw the vertical line, touches once, it is a function. Touches once is a function. What gets tricky, however, is this one right here, when it is a vertical line. These are not functions because the x values are repeating all the way down. If you were to pick different points on this graph and write them all out as ordered pairs, they would all have the same x value, which is what makes it not a function, okay? So if we did the vertical line test on this, basically it's like touching the whole way down, okay? It touches definitely more than once, if you want to think about it that way, okay? So vertical lines, not a function. Horizontal lines, they are a function. So with the vertical line test, you want it to only touch once. And the last way I'm going to show you today are ordered pairs. So here we have two different sets of ordered pairs. One is a function, one is not. I'm going to give you a second. Try and see if you can determine which one is a function. Okay, if you said the top one is a function and the bottom one is not a function, you're correct. The way you can look and see are these functions is if you simply circle the x values. You can circle the x values, you can cross out the y values, whichever way you want to do it, but I prefer circling the x values. If you also want to cross out the y values, that's cool too, okay? So on this first one, your x values are 3, 4, 0. None of them are repeating. This is a function. On the second one, 2, -1, 2. Here and here, they repeat. It's not a function. Does not matter that each of the y's is 3, because remember, we don't care if our y's repeat. We only care if our x's repeat. Okay? I hope this was a helpful mini review. If you are a student working on your online work, good luck. I hope that you're successful. If you're one of my students, please reach out to me if you have any questions. Thank you. Have a good day.